Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. Today both of us are wearing blue color, same color, right?
Yeah.
Okay, so today what do you want to do?
Sir, today I would like to work on the special products
Okay,
along with the multiplying polynomials.
multiplying. So show me what you're doing at school, and then accordingly I'll plan my lesson today. Okay, so you can share the screen with what
Right,
you
sir?
really want to learn, and from there we'll move forward. Is that okay?
Okay, sir. So I've just started sharing my screen.
Yeah, it is. Yeah,
So
I should.
this was what we have been learning. So we just finished special products. We have just started today along with polynomials.
Yeah.
So in the polynomials, it was basically first of a review of what we did in the last grade.
Okay.
And then for polynomials, we just multiplied. We started doing multiplication.
Mm-hmm.
So it was where we were doing multiplying polynomials and its exponents along
Okay.
with finding it, and then doing some word problems along with as well. Like for example, if the here's a square with x length and x width,
Mm-hmm.
right? It has shifted 6 units to the right and has lost 3 units down, then it's like creating an equation and finding how much more area is made, space or
Okay.
area is created,
Mm-hmm.
right? So like those questions we are working on for polynomials.
So let's go through
And
this and let's see some examples and then we'll continue with our lesson. Is that okay?
okay, sir.
Yeah, yeah.
And then we here was just a very brief part topic
So
of
multiplying binomials
yeah,
basically. Okay.
yeah.
Fair
And
and
then
simple,
its
right?
exponents like a plus b whole square and a minus b whole square.
Okay, yeah, yeah. And the model that's
Yeah.
something to look into, yeah, sure. No, not a problem at all. Yeah.
So like here's the a few of the equations like a plus
Right,
b minus a by b, which is a square minus b square.
right. And then with examples, some values.
Yeah,
Okay, continue.
and then the questions.
Yeah. So increase in area, for example, in this case, right?
Yeah,
Okay, continue.
and then like key
And then do it.
concepts like when squaring a binomial, you add the two equal middle terms after expansion, and then when you multiply the sum of the and the difference of two terms, then of two terms, the two terms are opposite, so they add to zero.
Correct. So I'll now take you to a whiteboard and we'll start from the very basics. I'll give you a special look and we'll visualize the solution. So today's lesson will be more about understanding how do we really, get these formulae, right? Both geometrically and algebraically, right? You see, understand now.
Yes, sir.
So I've seen what you need. Let me now tell you what we will be doing today. So we basically need to figure out what is product of binomials. That is what we need to figure out. And till now, what you've already learned is what I will say is prerequisite, or let me say what you know. What you know is distributive property.
Yeah. And then we also learned about like foiled serifs, like first, I think term, outer term, inner term, and last term, I think. So,
Yeah, yeah. So what you know is distributive property. So we'll start with distributive property, right? So let me take up an example. If I have A and if I want to multiply with B plus C, then what do I get? B plus C, I want to write.
so you would get AC plus BC. I
No,
mean, AC plus AB plus
AB,
AC.
A times B plus A times C. This is what you get. And that is the distributive property. So if there are more terms, you could also multiply them all using the same thing. For example, if I have A times B plus C plus D, right? Maybe some other number, let's say 2. And if I do that, what I get here is AB plus AC plus
AC plus
AB
AD
plus
plus 2A.
2A. Now, it is always good to write the numbers first and then the variable. And also, when we will write the variables, we'll write them in an order, alphabetical order. It'll be easier for us to combine the like terms. Is that okay?
Yes, sir.
So when you do this, maintain order. Okay. So let's begin with our examples where we'll take product of binomials now, straightforward, right? So now we'll look product of binomials, which means if I have a plus b and if I multiply with c plus d, what do I get? So first
You,
step, we have to multiply with a both the terms, correct? So if I multiply with a, c, I get ac. With a and d, it is with
80
plus sign ad. And now I'm going to multiply with b. When I do that, I get bc and bd.
MBD.
So we have four terms here, ac plus ad plus bc plus bd, right? So that is how it unfolds. Is that okay?
Yes, sir.
That is how it unfolds. Now, let us take special examples where we have a common factor. And now we look into one variable. Binomials. So when I say one variable binomials, I mean to say, like if I have 2x plus 3, now only variable is x, you get the idea.
Yes, sir.
And I could here have, let us say, 4x minus 5, correct? So that becomes one variable in both the binomials, correct? Now, if you expand this, then what do you get? So multiplying with 2x, both the terms, you get 2 times 4 is 8. X times x is x
X squared.
squared, correct? Now, with 2x and minus 5, we get minus 10.
Is 10x
Now let's multiply with the term.
plus 12x minus 15.
Correct. So with plus 12x minus 15. Now you can see very clearly that the center term here is
Is
like
between
terms.
like terms.
They can be combined. And when you combine them, what do you get? You get 8x squared
Plus 2x minus 15.
plus 2x minus 15, right?
Yes, sir.
So that is what that FOIL thing is, right? So what is FOIL? Can you tell me?
I think first, outer, inner, last.
So first outer and then?
I think it's first, outer, inner, last. I can't remember that.
Yes, first outer, inner, last. So how do you correlate with whatever we have written so far?
So like by using FOIL, I think like A and C, like first it'd be C, and then outer since it would be A and D, and then inner since B and C are close, and then last is obviously D, so then we'll just do that.
Yes. So what we did here is, see, if you look at it, then the product of the first terms is 8x squared. Do you see that?
Yes, sir.
The last terms when you multiply, let me circle it with a different color. 3 and minus 5 gives you minus 15, right? Is it okay?
Okay, sir.
Now we have outer and inner terms, right? So what we are doing is we are multiplying this outer and inner term, the combination of these two.
Okay.
So basically, if you look at it, first you did multiplication of A and C, correct?
Yes, sir.
AC. Then you did outer means AD. Do you see that outer AD? A and D
Yeah.
are outer. Inner terms B and C is inner. Do you see that B and C?
Yeah.
And then the last terms D and B, right?
Yeah. Okay, sir.
So can you visualize FOIL? First outer, then first outer, inner, last, right? So that is how, but you don't have to remember, it is so automatic and natural. You get the idea. Just
Yes,
as I
sir.
mentioned, you don't have to remember FOIL, right? Because remembering these short terms itself is a big problem. How many things will you remember? You get the idea? You
Yes,
have
sir.
to have a natural flow. If I am going to multiply a binomial with binomial, obviously, I'm going to first multiply with A, both all the terms, not only two, correct? And
Yeah.
then with B, the next term, all the terms. You get the idea?
Yes, sir.
So I have seen that those students who get stuck with these short forms, they really get stuck. It really stops them. And if I do a variation, if I write C plus D plus E, they will get lost because now there are three terms, not the binomial, right? Do they have another formula to remember for that? No.
No.
Simple steps. You get the idea?
Yes, sir.
Okay. Now, uh, we'll actually continue from here, but yes, foil is a very beautiful thing to market this particular thing by few people, but it is a distraction for students to learn and a hindrance in the process of learning. You get the idea. This is my
Yeah.
opinion on this. Is it okay? And I'm very serious about it. I'm not joking. I mean, I've seen so many students just thinking about foil and they don't know what foil is. Right? Now, for example, if I have 2 plus x and if I want to multiply with, let us say 3 plus x square minus, let us say minus x. Okay. Now, which foil will work? No foil will work, right?
No.
So,
None would
it
work,
has a
sir.
very limited application and it is not worthwhile remembering such acronyms, right? They only look nice, no good. Now, take the first term, multiply each and every term. You understand?
Yes,
Remember
sir.
this.
So like
Basic
6
process.
plus 2
6
square minus
plus
2.
2x square minus 2x. Now pick up the other term and
3
multiply
plus
all the terms
3x
in the next fraction.
plus
Continue this
x
process.
cubed minus x.
Once you do that, always write the numbers first, then the variables. Variables also in alphabetical order, x, y, for example, right? I'll use that.
Yes, sir.
Now you see, it is easy to simplify. We see that 2x and 2x minus 2x will
Cancel each other
cancel,
out.
and rest of the terms I should write in a proper order. Now, order means I have to write x cube first. So I write x cube minus x square
X squared
plus 3x
plus
plus 6.
6.
So that is how I'm going to work on. You get the idea?
Yes, sir.
Now, if you have missed some combination like terms, you can still do it. Now they are all in order. You get the idea?
Yeah.
That is how you have to do polynomial multiplication. Whether you have a binomial, monomial, trinomial, it does not matter. The process is same, correct? We did
Yes,
what?
sir.
We had a binomial
And
and
now we have a fourth
multiplied with a
polynomial.
trinomial. Do you see that?
Yes, sir.
So our process can be extended. It has no boundaries. It is a general process which can be applied. You get the idea? So this is what we have to follow. Perfect?
Yes,
Okay.
sir.
So I think you're good with distributive property and its variations, right? And its extension, right? So I'll call this as a extension of distributive property. Is it okay?
Okay, sir.
Okay. Now let's clear this page and look into more ways of doing it, right? Now I'll introduce you area model. So it's good to understand a model for doing this. We have one area model. You know what is area, right? So if I
Yeah.
have a rectangle, for example, let's say this is my rectangle, whose sides are A and B, then what is the area? So area is product of A and B, correct?
Yeah.
Simple as that, correct? If I have another rectangle whose sides are, now let me write down, this side is A, and this seems to be more than A. Let me write this as like this, A plus 1. Do you see that? I wrote it.
Yes, sir.
Now, tell me, what is the area of this portion?
That
A
would be
times
a squared,
A,
sir.
A squared. And what is the area of this portion? A times
That
1.
would be a.
So what I've shown you here is that A times A plus 1 basically equals to a square plus a. Is that clear to you?
Yes, sir. Meaning that like the rectangle, it has increased by a number, a units.
Yes. So, yeah, square has increased by a rectangle, another rectangle. Yes, correct. Now, if you expand, you can say a square plus a is equals to a square plus a, and that works, correct? So, algebraically, we see it the same as the geometric model. So, when we are multiplying this case, we multiply a monomial with a binomial, right? We see that the area model works. Is that clear to you?
Yes,
Correct?
sir.
Now let's try with binomials. So let me clear this. This time I want to multiply a plus, let's say, 3 with a plus, let's say, 2. In that case, if I make a rectangle model, how can I use this model?
You can draw it as like a square first, sir, and then like to make like a square, and then from there on you can add the extension of 2 and 3,
Perfect.
showing it,
I
and then
actually
from
like
there
your way.
on,
So what you
yeah,
said was draw A, right? Draw A
yeah,
first, right? Draw A first. So I have drawn A first, and then an extension of 2 and 3, right? 2 and
yeah,
3. I really like it. So I will do that. So extension of 1, 2, and 3. So this is 1. 1 and 1 means 3. And here I will do extension of 2 numbers, right? So okay, got it. So I got a very accurate drawing here. So this is like a plus 2 on this side. Is that okay?
yes, sir.
And a plus 3 on this side. Clear, right? This is what you meant.
Yeah,
I like that view. So draw that rectangle whose sides are, this is, let's say, length, and this is width. Simple as that. And how do you draw? Uh, you have given up a good technique to draw. So now let us split it into the squares, right? So we will just draw these 3 lines, and this is A, and that is 1, and that is another 1. So what do we get? Area of each. So now figure out the area of each. What is the area of this portion? A
a
square, right?
squared,
A times 1 is A, A,
a,
A.
a,
1 times A is
a,
also A, A. 1 times 1 is 1, 1, 1,
1,
1, 1, 1. And now you know the area is how much? We have A square
a
plus how
squared
many A's?
plus 5a plus 6.
So
So it
that
is
is the result.
increased by 5a and 6, the whole um shape itself.
The area, A square. Yeah. So if I expand, let us say A plus 3 times A plus 2. If I expand, what do I get? If I multiply with A's first, I get A square plus 2A, correct? And then with 3, I get plus 3A plus 6, right? So now I
Yeah.
combine A square plus 5A plus 6, which is same. Do you see that?
Yes, sir.
So this is exactly same. So when I write 3 lines instead of equal to, it is like an identity. You understand?
Yeah.
It is always true. So the model really works, correct?
Yes,
The
sir.
model really works. So that is how you can actually use model to multiply the numbers, correct? Now let's move on to a new page, and now we look into perfect square. So if I have to multiply a plus b with a plus b itself, what I'm trying to say is, what do you really get? When you multiply a plus b with a plus b, you actually could also write this as a plus b whole square, right?
Yes, sir.
Okay, but what is its expansion? So we'll again go to our area model and say, let us say we make a square whose sides are a plus b each. Is it okay?
Yeah.
By making a square whose sides are a plus b, that means one side is a, the other is, let me rewrite all the values here. Okay, so we have a plus b, and we have a plus b, right? So we have a plus b times a plus y, and we are using the area model. So now tell me, what is the area of this portion?
A square
Okay, let me write it.
plus ab plus ab plus
How about the area of this portion?
That would be AB, sir.
AB. And this portion?
That would be B square.
BA. So AB
Oh,
and B times A, I'll write AB
A.
because I will write all my alphabets in alphabetical order. Is that okay? I'm not
Oh,
writing BA.
sorry, sir. No,
Right?
I thought you were pointing
Yeah,
at the
yeah.
last one, right? That is why.
BA, no, that's okay. I understood. BA is same as AB, correct? Therefore, I will
Yeah.
write AB in alphabetical order. And then last square, which is just seen, B times B is B squared, correct?
Yes, sir.
So clearly, this expansion is what? Is A square plus how many ABs? 2, right?
2AB plus B square.
So that is the formula, which is called a perfect square. Is that okay?
Okay, sir.
We can verify, let's verify. If I multiply with A first, I get what? A square plus AB, right?
AB
And if I
plus
multiply with
AB
B,
plus B square.
I get what? AB
Plus
plus
AB
B.
plus B square.
So that is equal to the answer which we got, which is A square plus 2AB
Plus B square.
You see, writing AB is so logical. It helps you in adding. You know, these are the like terms, correct?
Yes, sir.
And we get our formula. Is it clear to you?
Yes, sir.
Now tell me, what is going to happen if I replace B as equals to minus C? Then what happens in the whole formula? So
In the
the
whole
formula
formula?
will be A minus C times A minus C, right? It should be
Yes,
equal
sir.
to what?
A
A square
square
plus 2AB
plus
times A, and B is replaced with minus C. Do you see that?
C. Yes, sir.
And B is replaced with minus C whole square, correct? So that gives me A squared, and that becomes minus 2AC, right?
Minus 2AC
And
plus
this is still
C
plus
square.
C squared because minus C squared. You see that? So basically what I'm trying to say is, we also have a formula for A minus B whole square, correct?
Yes, sir.
Just by replacing B with minus C. You could replace it with number, anything, correct? So let me summarize this result here. So we found that A plus B whole square is basically equal to A square plus 2AB
Plus
plus
B
B
square.
square. However, if I write this as minus, in that case, this becomes minus. It is almost
But
zero.
the rest stays the same. Just the B square.
Let us apply. So if I have x plus 3 whole square, what do I get? Tell me.
You get x squared plus 6x plus 9.
Correct. So 2 times 3 times x is 6x. That is why we got this 6x, correct? So if
Yes,
I
sir.
have x minus 5 whole square, then what do I get?
X squared minus 25x plus 20. I mean, minus 10x plus 25.
If I have 2x minus 1 whole square, what do I get?
2x squared minus 4x plus 1.
So 2x, this is 2x, right? And plus 1 square. So let me rewrite it. So I get 4x square. I didn't want to write it direct. So square of the first thing minus, because there is minus here, 2 times both these terms, so 4x and 1 square. Is that clear to you?
Yes, sir.
So let's do one more in this series, and let's write down this as 3x minus 2y whole square. What will I get?
That would be
3 square and x square is 9x squared.
9x squared
Minus
minus
2 times both these terms.
4,
2 times
12xy
12xy plus
plus
2y
4,
whole square.
4y.
4y. You get the idea. So now
Yes, sir.
we could take any value and we get that as our result. Is that clear to you?
Yes, sir.
Perfect. Now, I'm going to clear this and give you a test problem. I want you to write down the value of a plus b plus c whole square. Tell me what this should be equal to and how will you approach?
Whole
From
square,
A-
right, sir?
Yes, a plus b plus c. Can you use area model here?
Yes, sir, you can.
Why not use it? Correct? Let's make a area model, right? So we have this area model now. So we have a square whose sides are A, B, C, correct? Let us say this is a square, right? So whose sides are A plus B plus C. So let's say A, and then let's say B slightly smaller C, right? Do you see that?
Yes, sir.
So I'm just making different sizes of B and C, right? So that is what I get, right? Let me write down this A plus B plus C, and I write here A plus B plus C, correct? Write down the areas of each part inside. So this is what A square, right? This is what
Yes, sir.
A times B.
AB
This is AC. Now
and
let's go
AC.
to this. B times A, AB. B
AB,
times B is B square.
B square, and
Here
then
we have B.
BC
And here AC, right?
plus
BC.
BC plus C square.
So what do you get? So you get A square plus diagonally B square and C square. And then what? See, AB and AB can be combined, correct?
Yes, sir.
So 2AB, AC can be combined, correct? And these can
Yeah.
also be combined. So we get 2 times AB, 2 times AC, and 2
AC and
times,
2 times BC.
you see that? That becomes
Yes,
the
sir.
formula. Now, since we know the area model, I did not really do the distributive property. You get the idea. I did not do A plus B plus C times A plus B plus C. That could have given me how many terms? 3 with each, 9 terms to deal with. You get the idea?
Yes, sir. And it would
Just
have been
give
more
me
time
9
consuming.
terms, right? And then you
Yeah.
combine like terms, correct?
Yeah.
And then you get the result, right? And you could do mistakes in this, but here we have a formula straight away. You get the idea. So A plus
Yes,
B
sir.
plus C whole square becomes A square plus B square plus C square plus twice AB, twice AC, twice BC.
Plus BC.
Get the idea. You get the idea.
Yes, sir.
You see how useful it is when we try to learn logically, right? We haven't learned any formula so far, correct? We have derived the formulas using area model, nothing more than that. And also, A minus B whole square we derive just by substituting B as minus C. I could have substituted minus B also, correct?
Yes,
Anything.
sir.
Good job. So now let's apply this formula and find some interesting results. Let's say we have 2A plus 3 minus, let's say 4B whole square. Expand and write down the answer, please.
2A plus 3 minus 4B whole square, sir.
Yes. So basically, you're going to get 6 terms, correct?
Yes, sir. I got 4A squared plus 16B squared plus 12A minus 16AB minus 24B plus 9.
Very good. 2 negatives. Because of this negative here, when you say 2 times AB, so therefore, you will notice that I wrote 2AB. I did not do direct multiplication mentally, right? So since one of the terms
Oh,
is negative, so automatically we get a result. You get the idea. We do not have to remember the formulas of negative, right? Negative can always be substituted in one formula and you get the result, correct?
yes, sir.
So that is how we will understand how do we multiply the polynomials and also the special product, which is perfect square in this particular case, right? So let me now summarize. We learned three perfect squares, which is a plus b whole square is equals to a square plus 2ab.
Plus b square.
Yeah. And if it is a minus b, in that case, the only change is that this term becomes negative, right? Since b is negative, right?
Yes, sir.
And we also learned that if it is a plus b plus c whole square, then it is not very difficult. A square plus b square plus c square plus 2
Plus
times
2a.
ab plus 2 times ac plus 2 times bc.
bc.
Is that clear to you?
Yes, sir.
So when addition is involved, that is what we get. Now, we could actually also use it in the reverse order. So what we are doing here is, at the moment, we are doing expansion, right? So expand polynomials. But we could actually go backwards, correct? So if I give you a trinomial, you could write this as in the factored form as a perfect square, correct?
Think so, sir.
Yeah, we could do that. So we'll learn those factoring skills soon, okay? Till now, is everything clear to you?
Yes, sir. I was able to understand like how to expand the equation. That's fine. I just want to see how it would be like doing it backwards as check.
Backward, yes. Well, in expansion, one very interesting case is when we have a plus b, and not a plus b, but a plus b times a minus b. So if we do this combination, what do we get? Let us expand and check our result. So in this case, when you do a and this, what do you get? You get a squared minus ab, right? And if you do times b, then you get plus ab minus b squared. And that results into,
A square minus b square.
because these terms cancel, correct?
Yes, sir.
So this is called difference of square. So on this side, we have difference of square. And what do we have on the left side? Product of what? Sum and difference. You see that?
Yes, sir.
Does make sense. When you're multiplying product of sum and difference with the same numbers, you get difference of squares. For example, if I do, let's say, uh, 19 plus 1 times 19 minus 1, what do I get?
You would get
19 square
19
minus,
squared minus.
you see that? This is what I get.
Yes.
You get the idea?
Oh, yeah, sir. This is like the multiplication method that we did as well.
You did? Okay, good. So this is
Yeah,
what
like
we
you
do.
multiply it, you just round it to the nearest number and then you just add or subtract by how
Yeah, yeah.
much.
And what you did, I'll show you now. Application of this. Okay. Let's see. The application here is if I have to multiply 21 times 19, then what is this equal to?
So 20 plus 1 and 20 minus 1.
20 plus 1 and 20 minus 1. That gives me 20 square minus 1 square, and that is 400 minus
Minus 1.
that is 399. You see how easy it becomes? So you
Yes,
have
sir.
to apply the formula where it is required, not everywhere, right? Here it makes sense. So for mental calculations, this is a very beautiful formula, correct?
Yes, sir.
Correct. So we have used this application and now we know how to do this, right? Very good. So we have done this part. So we have understood now one more formula, and that is a plus b whole square we know as a plus a square plus 2ab plus b square. If I make this negative, then that becomes negative, correct? And
Yes, sir.
I also have learned one more formula, which is a plus b times a minus b equals to a square minus b square. Clear?
Yeah.
Now we'll see the application of these formulas. How do we really have many applications? Let us say that the what really happens is, let's say we talk about a circle as I saw in one of your examples. If radius is increased by 2, then find the increase in area.
Increase in area. Okay, sir.
Okay, not very concentric, but okay. So we have two circles, correct? So let us say area, this circle is R. And let us say that the outer circle here is, let us say,
2.
R plus 2. So what I'm interested in finding is increase in area, this area. Is that okay?
Okay, sir.
Well, the area remains same even if I have a big circle here and if I make a smaller circle somewhere there, right? Do you see that?
Yes, sir.
Even if they are not concentric. Do you understand?
Yes, sir.
And let's say this circle radius is from here, R plus 2. The result is same. You get the idea?
Yeah.
So if you take away a smaller circle from a bigger circle, what remains as the area? This is what we need to figure out. So the increase in area is, we know area of a circle is pi r squared, correct?
Yeah.
So area of bigger circle. So increase in area means, let me write delta, right? For increase in area. So will be pi of r plus 2 whole
Plus 2
square
whole square.
minus pi of r square. Right? It's like a square minus b square. Is it okay?
Okay,
Provided
sir.
I take pi common, right? So I have r plus 2 whole square minus pi r square. Pi common, so only r square. Is it okay?
Yes, sir.
So now you can do sum times difference, right? So add them and difference, you get pi is outside. And this is what? Add them, r and r plus r, add them, r plus 2 plus r, right?
Yeah, 2R.
I mean, it is this. There's less space here. So we have pi times, let me put bracket now, r, okay, r plus 2 plus r times r plus 2 minus r, correct? So pi
Yes, sir.
times 2r plus 2, right? And that becomes times 2, right? You will get
Yeah.
like this also. But let's do on a fresh page. Let's do on a fresh page. So basically what we are looking into is change in area, right? We are looking into change in area application. Now this is very important because if I increase the radius by a small amount, we find a very major change in the area, right? So in this case, I'm taking this as R and I'm purposely eccentric circles are being made here. So area of big circle, let me write big circle is pi times r plus 2 whole square, right?
Yes, sir.
Which you could write this as pi times, open this bracket, r square plus 2ab means 4r plus 2 square, which is 4. Is it okay?
Yes, sir.
Area of small circle is pi r square, correct? So change in area is area of big circle minus area of small circle, correct? So pi is common, so I'm taking pi outside. And the terms which we have now is, this is one term, which is r square plus 4r plus 4 minus we have r square. Is it okay?
Yes, sir.
And so r square cancel, and we get pi times 4r plus 4. Is it okay?
Yeah.
So that is what you can get. You can also write this as 4 pi outside r plus 1. So anyway,
R
of course,
plus.
it's the unit square, right?
Okay, sir.
You can actually get increase in area. Now, if you know the value of r, let us say r is 10. You can substitute r, for example, if you know r equals to 10, for example, then you can find out the change in area is what? Is 4 times pi times 10 plus 1. Do you see that? So 11, right? 44 pi.
Yeah.
We are given the value of r. So that could be one of the formulas, correct? Application of the formula, right? So, and then many examples we could have in this particular respect. For example, if I increase the length of a fencing, by how much will the area increase, correct?
Yeah.
So these are some very interesting questions which could be done. Now here is your challenge test question. Let me clear the screen. Okay. Let us say you have 100 meter of 100 meter of fence. Correct? Now with this 100-meter fence, you're trying to make different shapes. So you make some rectangular shape, you make some square shape, and you make a circle shape. Is it okay?
Okay, sir.
Which will enclose the maximum area? Tell me. And you have to find the value and tell me by how much is it more, right? So square is easy. Let's do for square 100 meters, right?
Yes,
So
sir.
each will be how much? 25.
25.
All are equal. So area will be 625, right?
Yeah.
Correct. Now, what rectangle really means if I increase one side and decrease the other side. Is it okay?
Okay, sir.
So if I make this, let's take random, some side. Let us say the longer side is, let's say 30 for me, right?
Yeah.
So this is 30, this is 30, 60. I've left with 20 each, right? 40.
Yeah.
Correct? So what is the area now? So area will be 20 times 30, which is 600, right?
Yes, sir.
It is less than the square. You can easily see, correct?
Yeah.
So from here, we know that the area enclosed by the square will be better. So if you want to use that fencing, you could use it in a square that will give you a very high area than any other rectangle. You get the idea.
Yes, sir.
Now, let's look into the circle. Can you tell me what is going to be the radius so that we can find the area of the circle? Well, we know that 2 pi r is the circumference, right?
Yeah.
And that is equal to 100, correct? So the radius is 100 by 2 pi, correct?
So 50 over pi, sir.
Very good. 50 over pi. So what is the area now? Area is pi r square, correct? So which is
Yes.
equals to pi times radius square, which is 50 over pi whole square, correct? So
Yes, sir.
we have pi times, what is 50 square?
50 square.
2500.
25.
And pi square. So one of the pi gets cancelled. So you get 2500 divided by 3.14, which is the value of pi. Tell me how much you get.
So divided by pi, sir.
3.14. Yeah.
Oh, 3.14.
Yeah. Out pi. Yeah. Give me one decimal place.
796.2.
Do you see it as much more?
Yes, sir.
So the area which you get when you use the same perimeter of the fence using a circle is even higher. You get the idea?
Yes, sir.
So That gives you an idea that if you are using this material, see the periphery is actually the material, correct? All around, correct? Fencing. Area is important for you because if more area, you can grow more animals can live. If it is a fence for the animals, they get more area to graze, for example, correct?
Yes, sir.
If there's a playground, uh, children can play, more area to play, correct?
Yeah.
And therefore, this helps you to design a playground also. If you have limited resources, then you can make some things which are squarish or they are circular in nature. Because you see, there is a lot of difference, correct?
Yeah.
Lot of difference. So the maximization of area for a given expense, which is the fence length, is calculated in this particular fashion. And you can, of course, use your formulas and techniques to factor and figure out what is the difference, right? General formula. Is it okay?
Yes, sir.
Right. So, general formula here means if I take r as my length of the radius, in that case, 2 pi r we could divide by 4, right? And get the length of the square and then compare in general also. You get the idea,
Yes, sir.
correct? So we could actually generalize and use factors. So Rohan, I think it's good for today. You learned a lot. Can you summarize what have you learned?
So in today's class, I have done a review on polynomials, like multiplying polynomials, and that I've also done like the, how do you say, the acronyms, like using FOIL,
Foil,
but then
yes.
also like having the chance to do it naturally as well, memorizing it naturally. And along with the doing some variable problems like a plus b or a minus b whole square, or even like a plus b plus c whole square, and all of them, and how I can also draw a diagram if there's
Area
a
model.
question that states it, and having the chance to review with my equation as well.
Very good job. So I'll summarize in one very simple thing which we have learned is write your equations in an order. That is very important. Squares first. And when you write their products, write the terms in the products also in order. Numbers and all variables in alphabetical order. You get the idea?
Yes, sir.
So when you write in order, it becomes easier to combine the terms and simplify. That's the whole thing, right? And
Yeah.
especially when you're also multiplying, go in an order. Pick up the first term and multiply each and every term in the other bracket by the first term first. Then pick up the second term, multiply each term with that. And then you get automatically everything in order. Combine them, write your result always in a proper order, right? Never you will see in a book A to B. No, no, no. We will not. We'll say 2AB, correct?
Yes, sir.
So this is very important. It shows uh, good methods to follow and to write so that it looks professional to even others who look at it, right? So that's what I'm trying to say. So with that, we can close our class today and we'll continue from here. Whatever difficulties you have, you can always email me or you can write as comments on my videos. Watch my videos for more practice also. Okay?
Okay, sir.
Okay, great. Thank you
Thank you.
and have a great day.
All right. Goodbye, sir.
Bye.